The functions of each pair in 12 through 14 are inverse to each other. For each pair, check that both compositions give the identity function. So G is from R plus to R plus. Those are the positive real numbers. And G inverse is also from the positive reals to the positive reals. They're defined by G of x is x squared, and G inverse of x is the square root of x for every positive real number x. Now, by the way, if this was from R to R and not from the positive reals to the positive reals, these would not be inverse functions. I think a lot of students think that these are inverse operations, that squaring is the opposite of taking the square root, that somehow those undo each other. That's not true. That's only true if we're talking about positive real numbers. That's definitely true if we're talking about positive real numbers. But it's not true when we're talking about negative numbers. These two operations are very, very different. Now, to show that these are inverse functions, we have to show that both compositions give the identity function, meaning if we plug x into this composition, then the output should be x. And if you plug x into the other composition, we should also get x. But we have to show this. To show this, I think it's better to use the other function notation here. Now, G inverse of x here is the square root of x. So we need to take the output of that function, the square root of x, and we have to plug that into G. So this will be the square root of x squared. Now, since x is positive, that's super important to preface here. Since x is positive, this is just x. The square root and the square cancel. Now, G inverse of G of x can be written this way using this function notation here. G of x is given by the rule x squared. So this is G inverse of x squared. G inverse is the square root. So this is the square root of x squared. Now, the square root of x squared, I really want to emphasize, do not just cancel out. The square root of x squared is actually the absolute value of x. Let's think about why this is. Most students don't really know this, mostly because it's not really discussed a lot. Now, if you square a number, you're never going to get a negative result. Even if you plug in a negative number into x here, like negative 3 squared is positive 9. And the square root of a positive number is positive. So if we plug negative 3 into x, the square root of x squared is actually positive 3. Now, there's another function that turns negative 3 into positive 3, and that's the absolute value function. Now, keep in mind, if x is positive, then the absolute value function doesn't do anything. And in fact, x here belongs to r plus. So x is a positive number, and so the absolute value of x is really just x. Those are the same thing because x is already positive. Keep in mind that if this was not from r plus to r plus, then this part right here would be where this proof falls apart. Normally, the function, the absolute value of x, is different than the function x, but in this context, they're the same because we're going from r plus to r plus. Thanks, everyone, and I'll see you in the next video.